Welcome to this lecture. In the previous chapter, we discussed the testing hypothesis for single population. We were curious about the population mean, population variance, and the population proportion. In this chapter, chapter 8, we are going to discuss testing hypothesis for two populations. We are curious about comparing two population means, two population variances, two population proportions. Let's start two population mean in case of independent sample. Here are examples for testing hypothesis for comparing two population means. It is a sensitive issue. Is there a difference between starting salary of a male student and female student who graduate this year? How can you compare that? Okay. Is there any difference in the weight of production produced in two production lines? Most of a factory, they produce some kind of product using different line. You might be curious whether they produce the same kind of product. Or suppose you give some training, special training for typists to increase typing speed. Well, this education will bring some more increase, really? That kind of thing. We'll discuss independent sample case. In a sense, we collect a sample independently from each population. Next section, we'll discuss some kind of paired sample. Here are testing hypotheses for two population means. As we did before, there are three types of the hypothesis. Well, it means we are curious about the conservative decision making. We don't mind about the beta. We are curious about the testing based on the significance level, some allowable type 1 error. There are three cases: greater than, less than, or not equal. Well, you may say mu1 equal mu2 if d0 equals 0. It is some kind of generalization. Okay? You can just compare mu1 equal mu2 or mu1 is greater than mu2 in case of d0 equals 0. How can you do testing about the two population means? You need some kind of sample statistic. Well, in order to estimate the difference, well, the best candidate would be the sample mean difference. Yes, this sample mean difference will be used for testing hypothesis. Then, what you are supposed to do? You are curious to know about the distribution of, well, let's use this draw. We are curious about the distribution of this sample mean, what it look like. Okay. Well, in most of the cases, the sampling distribution will be studied first. But well, it is beyond of your level. I mean, this is the introductory course. The mathematical statistics will deal with how to derive the sampling distribution. Let's accept that, but you might have some idea. This is not practical. Suppose you know the population variances are known. In this case, well, the sampling distribution of sample mean difference follows this kind of normal. Remember that? The sample mean follows normal distribution. The mean was mu1 and variance was sigma 1 square divided by n1. Similarly, the sample mean x2 bar, if you collect the sample, calculate the sample mean, the all possible sample mean follows mu2, mean is mu2, and variance is sigma 2 square divided by n2. It look like similar to previous chapter 7. We discussed this sampling distribution in chapter 6. Well, the distribution of x1 bar minus x2 bar, well, the mean is mu1 minus mu2. The variance is just the addition of them. You can guess, what it look like. But maybe you may write down as a normalization, subtract mean divided by the standard error of this statistic. That's a square root. It will be normal 0.1. Well, you need the mathematical study. Suppose you don't know population variances are unknown. Okay? In that case, well, if you see these things, you can see the analog. You replace the unknown population variance with some kind of variance. We call this is pooled variance. You replace that with SP square. Then it becomes T distribution with this degree of freedom. If you understand the chapter 7 idea, if I specify this sampling distribution, maybe you are done almost. Okay. Well, what is SP square? We call pooled variance. This is a mathematical formula. Can you guess what it looks like? Since the sample size of population 1, so N1, is different from the sample size of N2, it looks like a weighted average. Okay? N1 minus 1, N2 minus 1, it also used to calculate the sample variance, therefore using these things as a weight. Okay? Well, it is some kind of proportion of N1 minus 1, proportion of N2 minus 1, we call it is pooled variance. Okay? Since we assumed two population variances are same, therefore we can pool. Okay? That's the case. Okay? When practically we don't know the population variance and these population variances are unknown, then we are using this sample statistic. What would happen if you cannot assume the variances are not the same? Then there is some slight variation. It looks like this. If it is unknown, it is again T distribution, but approximately the degree of freedom can be calculated using complicated formula like this. Except this degree of freedom, well, it is very similar, but here you are using the sample variances, each sample variances. Well, depending on whether you can assume the population variances are the same or not, we are using slightly different formula. If I summarize this finding, the testing hypothesis when population can be assumed, population variances can be assumed the same, then we are using this test statistic. Okay? if H0 is true, it is conservative decision making. If H0 is true, then mu1 minus mu2 equals 0. Therefore, you normalize in this manner, and we are using this kind of T distribution. Depending on the alternative hypothesis, well, you can have this critical value, or negative of that value, or absolute value is half of alpha. If you understand chapter 7, maybe just introducing sampling distribution, you can immediately find this kind of formula. Suppose you cannot assume the two population variances, they look like different, then that's just replace, instead of pooled variance, you are using actual S1 square, S2 square, but you are supposed to use T pi degree of freedom. Okay? Well, the other thing is similar. Let's consider example. Suppose two machines produce a cookie. Okay? It is supposed to be 270 grams. Our samples are extracted from machine 1. There are 15, and the sample mean is 275. But standard deviation, sample standard deviation is 12 grams, and average weight of 14 packages. Extracted from machine 2 was 269, and standard deviation was 10 grams. We want to test hypothesis. How can you do that? Well, suppose you can assume, here's the assumption, suppose two population variances are equal, then you can use a pooled variance. Okay? These are the test statistics. Sample mean difference minus D0, but if you are saying mu1 equal mu2, that means D0 equal 0. Okay? It looks like x1 bar minus x2 bar divided by standard error. These are the summarization of the given information. Sample size is 15, 14 each. Sample mean look like this. Sample standard deviation look like this. Therefore, well, the pooled variance is weighted variance, like in this manner. Okay? You have a sample 15, 14, because of we are using 15 minus 1, 14 minus 1 to calculate the variance. You multiply n1 minus 1, n2 minus 1. It is some kind of weight. Okay? It becomes 122, 815. Can you see that the first sample variance, if you scale over this one, 144, this is 100, it is somewhere else in the middle, right? This is, by using this pooled variance, you calculate the test statistic, because it is a two-sided test, therefore it is 1.457, and your critical value, if you are looking at this degree of freedom 27, that is 15 plus 14 minus 2, and then 0.005, because the significance level is 1%. It looks like this. What is your decision? This is less than your critical value. This is two-sided test. Therefore, it is inside of acceptance region. You cannot reject 0. Well, let's practice in a minute. And after we discuss next example. Well, suppose you cannot assume the population variances are not the same, then you have to use another T distribution. You have to calculate degree of freedom. We found this one. Approximately this value, this is some approximation, is 2773. If you compare with the previous one, it was 27707. It is slightly different, okay? Not big. Okay? but sometimes it is matter. Same thing, you cannot reject H0. How can you practice in E-step? Well, maybe E-step U would be better. Are you ready to use E-step? Click E-step U button. There are testing hypotheses for mu1 and mu2. Maybe default is alternative hypothesis not equal, D in this case 0. And you want to have 1%. The variance assumption is you can choose either same thing or the other one. We don't know the data, but you have some information about the N1, N2. What is N1, N2? Okay. What was the N1, N2? These are the summarization of your information. N1 is 15. Okay. And then N2 is 14. And then sample mean 275, 269. And then variance was 12 square and then 10 square, that's 144 and 100. Then you are ready to practice. If you click execute button, well, they show you the statistic. Test statistic, it looks like this. P-value is inside, therefore it is more than 15%. Well, that's it. You cannot reject H0. Suppose you select this alternative, this assumption, variance assumption is not equal, then you can have almost the same thing but slightly different, right? Because you are using another kind of t-distribution. Previous one was 15 plus 14 minus 2, what is that? That's 27, but this is 26.7. It's a slightly different. Okay, what's next? Okay. You can practice easily using E-step. We discussed this problem. Let's discuss one more example. You have real data. Okay, you have to compare male and female population college graduate, and you are checking the monthly average wage. You want to test that. I think this example is in E-stat. Maybe we can exploit their data set in eBook. Go to E-stat, click here, eBook. Where is eBook? And then we are talking example 11, 0. No, we are talking example this one. Okay, wage by gender. Okay. Here's a formation of data input in case of testing hypothesis of two population. Well, you enter income and you create a column on gender. That's a typical data input in case of testing hypothesis of two population mean. Here's an icon for that testing hypothesis for two population. And what they are supposed to do, analysis variable, the main concern is income. Click here. The by group, you need to select group. You have two groups. We are comparing two population. It looks like this. This is first half. You are comparing two population mean. These are the confidence interval. you can immediately notice that the confidence interval overlap, therefore maybe testing hypothesis, there would not be a difference. Okay? That's your intuition from this dot graph. If you want testing hypothesis, you select confidence, maybe significance level 1%. Then if you are selecting t-test, you will have a similar output in East and U module. Okay? You can see that the test statistic look like this. It's very inside of this sampling distribution. Therefore, well, its H0 should be accepted. Okay, I hope you understand this testing hypothesis. Maybe if you understand the chapter 7 testing hypothesis, it would be very similar. Okay. Well, next class, we are going to discuss testing hypothesis of two population means in case of a paired sample. We'll discuss what does it mean, paired sample.